This way too much. If you watched the video, you saw at the very end of me doing the homework problems, I started secant and cosecant. I threw it at the end. If anybody saw that, I'm not going to ask if you did. But anyway, cosecant and secant are super easy. And so I'm going to spend very little time on them, okay? Let me show you how we're going to graph secant and cosecant. At first, it's going to look crazy. All right. So this one is cosecant. That's actually one I did in the video. So if you want to fast forward to the end of the last video, you would see that. I also usually load them under topics in case you kind of lose your place in the assignment when you go back and look at previous. Most of the videos are under class notes, okay? Even the extra ones. Anyway, it's a pain in the neck to type in cosecant, cotangent, all of that correctly, okay? So I do not suggest doing those on your calculator. But anyway, I'm about to graph this cosecant. The vertical translation, which would be the average between the amplitudes, is 3. The amplitude of this is 4. And here's what a cosecant graph looks like. What you'll see first is your vertical translation line. Another thing I did in the video was I actually moved the axis. It's kind of cool to maybe watch the end of it. I took the axis that you're used to, and I moved it like over and up so that you could actually see that target if you were just going to start a new sine graph from. Okay. So anyway, you're going, okay, sorry, that was not really easy. Okay, it was really bizarre. These are not parabolas, but they're, I think that's our first instinct, is they look like a bunch of parabolic shapes. The reason I'm being kind of picky about that is they really go down severely, whereas a parabola goes out from negative infinity to positive infinity. These are more, I don't know if you know what a catenary curve is, but anyway, they're really more steep. They're still going out a little bit. They're getting infinitely close. They have asymptotes. You see tons of asymptotes. It kind of goes along with our rational function. They are just undefined over and over and over again. Let me tell you where they would be undefined over and over and over again. Whenever sine was 0, cosecant is going to be undefined. Do you remember how many times sine was 0? Okay. So how is this easy? Watch this. Everybody in the room should be pretty comfortable with the third graph right now. What I have in Y3, you should go, yeah, I can do that now. And I really, stretch your information when I gave you data and you have to write your own equation for the project, okay? So anyway, and we'll practice that a little bit more on Monday also. So anyway, everybody could graph that one. So watch this happen. Hang on.
Wait, I'm confused. What is
All right, wait just a second, Nicole.
Sorry.
Hang on. Just wait. It's going to be one of those times if you wait, you're not going to have any questions. So just don't forget your question, okay?
Okay.
Here comes sine that you should know how to graph. And look at cosecant. Cosecant is I love pictures are worth 1,000 words. They're reciprocals of each other, okay? Do you see it's really turning sine upside down over and over again? So I'm going to explain it. So let's look at this. Okay. All right, let's just pretend like that it was just the most simple sine wave in the whole world, because now that I don't have my equations, I can just talk about the black graph as y equals sine x for a minute, okay? Where let's say this is 0, 0. And sine goes up 1 and down 1 unless I gave it a different amplitude. Everybody okay so far? Okay. What's the reciprocal of 1? 1. Okay, isn't that how I would find the cosecant of any given angle? I would find the sine of the angle and take the reciprocal. What's the reciprocal of negative 1? Negative 1. So all of these are going to be the same. The reciprocal of 1 is itself. And so those lock on. Now, sine of 30 is 1/2. So what's the cosecant of 30? 2. And as this gets smaller, Let me do it in yellow. As this gets closer to 0, like 1/10, what's cosecant going to be? 10. How close can you get to 0? So this goes really high, doesn't it? 1/100th, 1/1000th. So do you see how this has gone off to infinity, like our vertical asymptotes, okay? Right here, sine is 0. Again, I love the literal aspect of this. Graphically, they are literally reciprocals of each other, okay? Also, numerically, it's interesting to talk about. Hang on, don't ask questions just for a second, but please don't forget them. Write them down if you think you have them, if I don't answer them. What's the reciprocal of 0? 0 over, it could be 0 over 1 or 0 over 8. You don't know what it is, but it's 0, right? If you flip that over, it's going to be undefined. And what's the opposite of having nothing?
Having everything.
Having everything. These are going off to infinity at those asymptotes. Do y'all see what I mean? So at 0, you go, this is undefined, because that would put 0 on the bottom. So everywhere at 0, you have asymptotes. All right, so what I will show you to do is this. When you have to graph, y is equal to, second page of your worksheet, the ones I haven't worked yet. I think it's the one with the 5 in it. Okay, so let's say I want you to graph 4 cosecant x minus pi plus 5. Okay? And then just go, okay, well, I'll just graph sine and take its visual reciprocal, okay? Its graphical reciprocal. So for just a minute, I'm going to treat it like sine. All right, so what's the amplitude? 4. What's the period? 2 pi over 1. Coefficient, okay. Are y'all okay? Count is going to be, are y'all all right with pi over 2? Phase shift? Pi. Vertical translation? 5. This is my starting place, my new target. I'm going to add this to that in just a minute. So I'm going to move over pi and up 5. By the way, when you're graphing sine, cosine, secant, and cosecant, the numbers 4 plus 5, 9. This plus your amplitude is 9, and this minus your amplitude is 1. You should already know your range is from 1 to 9. You're at 5, and you can only go 4 up and 4 down from that, okay? So this is my new target. I'm going to count by pi over 2s, so I'm going to change this to 2 pi over 2. So my next mark, I'm going to make it about half as big. My next mark is 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. Questions that people have come by and asked me like, wait, I thought the period was 2 pi and you've gone out to 3 pi. But really I've marked off, and this was a history graph and these were dates. I've marked off an era or a period of time which is 2 pi, haven't I? My whole graph's going to happen from here to here, which is 2 pi radians. All right, now it's sine, so is everybody okay if I put it on the target? It's positive sine, so I'm going to go up 4 first. But nobody asked me to graph sine, so hold on. I'm going to go up 4, down to the middle, down 4, and back up to the middle. This is what my sine graph would look like. I'm dotting it in. In the video, I said almost like an asymptote. I can't call it an asymptote because it's not a line, but it's kind of an in-behavior model, okay? Because I want to flip over all of those numbers in just a minute. I don't have to learn anything new. This is where it's important to also get more going because I need a pretty good graph here. I need more information. So it came from middle, down, up, then high, back to middle. So I have a couple of periods of this going on. Okay? Now, we'll do this in white. Everywhere that sine touches the asymptote, sorry, I said the wrong word. Everywhere sine touches that middle line, you're going to have asymptotes. Okay? Then you meet at the amplitudes, let them touch right there, and then draw it upside down. You're taking the reciprocal of all those numbers. Let it meet at the asymptote and flip it upside down. Meet at the asymptote, and also stay, the asymptote will tell you the width of those U-shaped things, okay? All right, now technically, the cosecant graph is just white, so I guess technically if I wanted it to look really pretty, I would erase the dotted lines and you would just see a cosine graph. You don't have to do that. You can leave the dotted line in there, okay? For people that really, once you get moving on this, a lot of my students in honors, I don't care if you do this, but a lot of people will do this. They'll go, I don't want all that mess in my graph. So they'll go, oh, it's a sine wave. I'm going to start on my target. All you need is the high, middle, low, middle. And they won't draw the sine wave at all. They'll just keep going high, middle, like that. Everywhere that this black dot is on the midline, it's undefined. And y'all see how you meet your highs and flip it over? Meet your lows and flip it over. That's a personal decision on your part. I don't care, okay? So now I'll graph to cosecants. I remember going, okay, got that. That was really easy. All I had to do was know how to graph sine and cosine, and I could graph secant and cosecant super easily. But it really bothered me, okay? And that if this is 5, the reciprocal of 5 is not undefined, okay? The reciprocal of 5 is 1/5. But did you see how I slapped those asymptotes where it was touching the midline? And then I thought about this number. What's that number, 9? The reciprocal of 9, is it 9? It's 1/9. So I was like, what's my teacher thinking? Okay? So you may not even been on your radar, but you're a big enough class and curious enough to where you probably at least now wondering, whoa, hang on, is this okay? It's an order of operations in this happening. So I'm just going to tell you, I had to settle it on my own mind. So I probably sat down for 30 minutes thinking about it when I was your age, unfortunately. That explains a lot. All right, so when I put in pi up there, what's pi minus pi? You see, that's the moment the angle is 0. Okay, sine of 0 is 0. So when I try to move forward and take the cosecant of it, it falls apart before I ever get to do anything else. Do y'all see what I mean by order of operation? Now let's see where it's 9 at 3 pi over 2. 3 pi over 2 minus pi is pi over 2. What's the sine of pi over 2? 1. So what's the cosecant of pi over 2? 1. Once you get the 1, you multiply by 4 and add 5. So do you see that that does work?
Yeah.
Okay? So, anyway, they both meet at 9. Everything will work, though. I hope I've explained it to you at least where you're like, okay, at least she figured it out. All right? So I'm going to do another one, then I'm going to take questions. Let's look. Oh, by the way, hopefully that helped you on the graph. This is actually what your graph should look like. What's awesome about these, I'm already noticing as I come around the room, most people's looks just alike. It's pretty easy to grade. You may, hopefully you followed that. Sorry for me coming to grade all these numbers and waves and graphs and everything. It's a good thing you don't throw things at people during class. I hadn't had that happen to me ever. Okay, sorry, Bella. So anyway, I will get in there and look at the picky stuff. You know, if you get really tired of writing all of these down, as long as you write enough down for me to know what you're counting by, I'm good with that. Okay. All right. So now I just hope I did number 1 on the back side for you, and also showed you how to graph cosecant. You'll have some cosecant and cotangent. Sorry. You'll have some homework on all the trig graphs that I'm talking about today. All right. So now let's go to number. And I'm sorry, I think in class with you, not on the video, but in class with you, I think everyone I've done is slid to the right. There are some that slide to the left, which is why I changed some things. I just got carried away with copy and paste on this thing. Okay, so let's do number 4 on your sheet. Number 4 on your sheet is 5 plus 5 cosine 3x. I think I changed it to plus pi. Did y'all make a note of that? Always read the whole assignment, okay? All right, so we have y is equal to 5 plus 5 cosine of 3x plus pi. Now, on your test and on your homework tonight, if you see 5 plus 5 secant 3x plus pi, just graph cosine, and then, sorry, I just thought of something I need to tell you. Graph cosine and then flip it over. Take its reciprocal. Not flip it over. Take its reciprocal. I need to desperately go back to this and watch what I'm going to do with my pen, okay? It's not really the amplitude in this case. It's really the stretch. Why can't I call it true amplitude? Because my cosecant graph's going off to where? In fact, the only place it doesn't exist is during that amplitude time. So the only two graphs that have amplitude, I mentioned it didn't make any sense back a while ago, but you can start to see sine and cosine are the only ones that you could change the amplitude on. You've heard the word amplitude before, by the way, AM and FM radio. AM stands for amplitude modulation. And so that radio station, you're picking it up because it's amplitude of the wave coming in, gives it a different station. FM radio is frequency modulation. So it has to do with changing the period of whatever your radio station is. Okay? So do you see secant and cosecant don't have amplitude? They go off to infinity. I couldn't name their amplitude. So if I ask you the amplitude of a cosecant or a secant or a tangent or a cotangent graph, say there is none. I'm not trying to trick you. I'm just trying to see if you know. Okay? It might be better if I just called it the stretch. What do I mean by stretch? Can you see the amplitude of sine would dictate the stretch of cosecant? Do you see how I could move the amplitude down and all those u's would come down or stretch up? Okay? All right, so one period of a cosecant wave consists of an up and a downward u thing. Okay? All right, now back to this one. All right, so no questions right now, but please write them down, Pietro. Don't forget what you're going to say when I finally call on you. All right, so the amplitude, what's the amplitude of this graph? 5. When I get ready to graph this graph, it's going to be the stretch, okay? You still need the number. So I'm going to call the amplitude 5. Period is 2 pi over 3. The count, a fourth of 2 pi over 3 is pi over 6. Phase shift, negative pi over 3. And vertical translation, 5. This is my new 0, that's my new origin. And I'm going to add pi over 6 to that. So I'm going to change this to negative 2 pi over 6 so that I can add. All right, so it's moving back pi over 3. And I'm going to add by pi over 6's, which are half as big. Negative 2 pi over 6 plus pi over 6 is negative pi over 6. Plus the next pi over 6 is 0. Plus the next pi over 6 is pi over 6. Plus the next pi over 6 is 2 pi over 6, which is pi over 3. I'm going to go to right here, negative pi over 3, 1, 2, 3, 4, 5. And this is my target. If it's sine, I'm going to put the dot right there. But it's not sine, what is it? Cosine. So the dot should start up here. Oops. The dot should start up here at 10, right? You should go up 5, from 5. So my first dot is actually going to be up here. Always mark off 6, 7, 8, 9, 10. Okay. So my first dot's going to actually be up there because it's a positive cosine. Then my dot goes to the middle. Then it goes down low, comes back to the middle, and back up top. I'm going to mark off a few more. I was at top, middle, low, middle, top, where am I? Middle. Okay. One thing I wanted to tell you, all of these cool things that I'm showing you, cut way down on your graphing time. Remember the worksheets I gave you at first where you had to find all those points and connect the dots. So all of these tricks are really cool. Find 5 main points and divide it into 4 equal parts. You find the high, the middle, the low, the middle, blah, blah, blah. Okay? But you can always check your work if you get nervous. Like, let's fill in 0 and see what we've done. Go way up there, and if you put in 0 for x, you'll get cosine of pi, which is -1, times 5 gives me -5, plus 5 does give me 0. Those dots should match up with what you have, okay? All right, now if this was cosine, I would just connect my dots in a real smooth fashion. Okay, but I'm going to undo this, and now I'm going to graph secant. All right, everywhere it hits the midline, I have a what? Asymptote. So draw those first. Get your bars in. Everywhere it hits the midline, you have asymptotes. Okay, then I'm going to meet the high, touch it, and flip up, because cosine would have been coming through like this. The low, you touch it and go under. High, low, high. So hopefully that helped you check something on your worksheet and graphing secant. Okay, now let me take questions. I hope you remember them. Elena?
If the amplitude is of like the cosine graph is 5, then it would be like a 10 stretch, like the distance between the vertexes or whatever.
Right. From wherever your midline is.
It'd be 10.
Yeah, so if my midline was 3, I would go 5 above that and 5 below that, and that would be a total distance of 10.
I don't know if this makes sense, and I don't know how important this is, but I'm kind of curious to know what the relationship is between like the stretch and the shrink of like the sine graph, for example, and like that the relationship of that with the cosine, with the steepness of the cosine, the parabola.
The U shape, yeah. Well, obviously the period, if it makes, I may not, tell me if I'm not answering your question, but let me try. If sine has what we call a low frequency, or in other words, a long period, then those U's are going to be wider. If sine is very frequent, those U's are going to be really close.
Is there like a numerical?
They're reciprocals of each other, so, oh, I see what you mean.
Like,
Yeah, you would know how wide they are. They would be half the period of the sine wave. Is that kind of what you're looking for? Does that make sense, though? Because there's one of each. So you could find the period, cut that in half, and you would know the width of each U. Okay? Other questions or comments? Okay, Nicole?
When was on the graph, like when you did the graph on your like computer, it didn't have like on the y equals part, like when you go on that like window.
Wait, so I'm not here. Oh, am I going to window?
Like just the y equals.
Okay.
What does that like -0 mean?
Oh, I'm able to, the reason I do that is this. All I did was, it's not really a -0. That's a good question. You can go all the way over here, and I usually just use this as a teaching tool. I could go down here, and there's times I might want to make things, sorry. I usually have to have the calculator in my hand to actually do, okay. Do you see I can go here? I have to do it on my actual calculator. But I can just keep clicking this and it'll do different things. So I like to give it what I call a tail so that it won't just graph it all at once, that you actually see it come in.
Oh, you see it. Oh.
And so it just gives it like a little, I wanted to see your eyes hitting all of those sine things. Okay? You don't have to be able to do it, but it's nice to know how, because you might want to. I can make it bold or dotted or whatever. Okay, now let's do tangent and cotangent, and you'll have time to practice these. It's one reason we didn't put the test on Monday. I just still don't know what today is. Okay, so,
If we were just given like the graph and it had like all the x values and stuff, would we be able to like decipher what it is in terms of sine and cosine?
listen to this great question that Isabella's asked. That's so great. And I think Michaela also addressed it with me this morning. She was looking at her temperature wave, and she had written it as a cosine, and she said, could I write it as a sine? I'm like, yeah, you could. Your shift would be different. But what Isabella, I think, has realized is that where I could make the same picture with putting the word sine and putting the word cosine in. I would have to manage my phase shift to make it land. But if all you see is the graph, you really don't know what someone's typed in. So it's not unique. Usually people use sine, but just because it just comes to mind first, if they're writing a program or something to do it. But like once I saw the weather, they started this in January, so it was cold, so I thought of a negative cosine wave. That's a great question, and probably something, if I don't give it to you before the test, we'll look at some of that where I give you a graph and you write the equation, but you might write yours with cosine, and Rebecca might write hers with sine, and your amplitude and period and vertical translation would all be the same, but your phase shift would be different. Because where yours is high, if she's sine and you're cosine, hers would need to be like, yours would need to be shifted over. Yeah, like I can do it here instead of waving my hands in the air. Okay, so this graph, I could actually, let's turn this off. Let's turn this off. I don't want this cosecant graph. What if I wanted to write an equation with what Isabel's asking me? I'm going to say -4. Just ignore the middle one. I'm looking at this one. I'm going to go cosine of 4x. I don't need that. 4x. And then plus 3. It's not going to be correct yet. Well, that's aggravating. You got to wait for the vertical translation to come in really slow. I can get rid of that too. Do y'all see where she's headed with this? So it says I can write it as cosine, but you see I'm going to have to figure out how to shift that over, okay? And then let's see, I don't have any points here that I can look at, but however far apart these are, that's how far you'd want to shift it over. I don't know why I don't have marks. Oh, because I turned my axis off. So I could turn my axis on. But I'm not going to do all that right now, but you can. They are pi/2 radians apart if they're unaltered. If you can shift cosine over by pi/2 and it'll land on sine. Okay? But once you change the period, that's going to change. So you could probably come up with a formula, but it's easy enough to figure it out without
What's the difference? What even is like the difference?
If it's just unaltered, if you haven't changed the period of it, it would be pi/2 radians.
So
Hey girls, look, this is great discussion. I need to move on, but I can't resist these two girls' questions up here. On your memo page, you have this written. This is super cool now because I love to merge all your information together. Does anybody remember the cofunctions? We haven't done much with them. Cosine of pi/2 minus theta just equals sine of theta. So what Isabel and Rebecca are referring to is what should happen if I graph this and this. I'm not going to do it right now, but if I did, they would be exactly the same. Okay? Now this, I don't know, I didn't want to get into that today. If I have time at the end, I will, but good questions. Okay, now we're going to learn how to graph y equals tan and y equals cotangent. All right, you want to actively, trust me, and listen, okay? Because these twisty turn in opposite directions in different places, which is why it's like I planted you in the audience. Sine and cosine are shifted over of each other. So Isabel's question, if you see a wavy graph, Isabella could write it as a cosine and Lauren could write it as a sine, and they could both be right. They just have different phase shifts, okay? Tangent and cotangent will confuse you unless you listen to me, and I'll try to unconfuse you as I go. But if you're not really engaged, which never happens in here to my knowledge, you'll get confused, I'm just telling you. And did Zena just walk out? I really needed her. Okay. So anyway, I'll refer to her in a little while. Okay, in fact, I'm going to have to go ahead and do it now. She's going to miss it. But when she gets back, I'll.
Is
Is she here? Oh, thank you. Your teacher is writing on her hands with a Sharpie.
That was so funny. That shit's exactly like it.
I just couldn't tell you apart.
I'm flattered.
Are you like the
Okay. So anyway, now I'll probably touch my face and have like tattoos on my face. This, okay? It'd be worth it if it would help you learn. Okay. So look at this. This is challenge, shape, and change the world. Okay. Do y'all see all the CSCs here? Okay. And what's on my thumb? C. Okay. Sine, cosine, secant, cosecant, cotangent. I'm glad that God gave me 5 fingers on each hand. If I had 6, this would be confusing, so I'm glad it's over here, okay? Which plays into why I need Zena, but I'll explain that one. Sine, cosine, secant, cosecant, cotangent. Tangent's over here by himself, okay? They're both short. Y'all see what I mean? Okay? The period of sine, cosine, secant, and cosecant is 2 pi. All right? What does that look like? Pi? The period of tan and cotan's shorter. It's just pi. They're finished early. I'll explain why. All right? Tangent and, do you see my little pi? Just imagine a little line over it. Okay? Do y'all see what I mean? All right, so sine, cosine, secant, and cosecant's normal period is 2 pi, and you just go 2 pi over. With tan and cotangent, you're going to go pi over. This is where you will get confused. I put cotangent over here with the CSCs, and it's convenient that it starts with the C, so it goes with the CSCs. It acts like all of these, and that you start and go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Tangent's different. But the reason I put it over here is once you see tangent, a lot of people start to do cotangent like tangent. You'll see what I mean as I go, okay? So, one thing you should wonder is why I don't, I'm probably just getting this all over me, why I don't teach tangent and cotangent, they're reciprocals of each other. It's real confusing to flip these over, okay? So I just teach them individually. Most everybody does. All right, look at all students take calculus with me real quickly. All students take calculus. I'm just going to talk about sign right now. Positive, positive, negative, negative. Okay? All students take calculus. This is sine. What would cosine be?
positive, negative, negative, positive?
Positive, positive, negative, negative, positive, negative, negative, positive. Let's look at tan. And it's reciprocal. Positive, negative.
Positive, negative.
Okay, so these numbers go like, if I'm doing a sine graph, I get like positive 1/2. It comes back down through some more positive 1/2. Then I go into the negatives, and then I come back up, right? So it takes 360 degrees or 2 pi radians for that to happen. Look what tangent does. It goes through all of its numbers, positive, negative. Sorry, that was cosine. Cosine goes positive, negative. It's in the positives, then it's in the negatives, and then it's in the negatives, and it's in the positives. Do you see tangent goes positive, negative, and then its pattern is different. It goes positive, negative, what? Positive, negative, positive, negative, positive, negative. Do y'all see it's finished with what it's going to do by 180? It's going to start over again. Think about that as I find the period shorter because it's through with that cycle of when it's going to repeat the numbers. This order, positive, positive, negative, negative, doesn't happen again until you go all the way around. But positive, negative, positive, negative. So the period of tan and cotangent is just pi or 180. Okay? But look, my thumbs are shorter. All right, so Zane, I think this is you. I think that you and I did this in algebra when you're sitting at my desk one afternoon. When I just said I'm glad that I have 5 fingers on this hand and.
Oh no, yes, I remember this.
I gotta
Oh my
find
goodness,
the
I remember
picture.
this.
Okay, so in class I always say I'm glad that I have 5 fingers on this hand and 4 fingers and
With
1
George.
finger on this hand, but my brother Jed has 4 fingers on his hand.
No way.
I remember
Yes.
that.
Yeah, because you
And
said
so
the
I'm
photo
always
was
like make a
close
big
to
deal
fingers.
about it, and I go, oh, so he couldn't do this, you
Yeah, I
know.
remember
He
that.
didn't have his wedding ring finger, so I used to tease him he can't get married, but he did. But anyway, so anyway, he's a great sport. He was actually at a business meeting when Zayna and I did this. Zayna was sitting, I guess I told your Algebra 2 class for some reason, but it really goes into my sine, cosine, secant, cosine. So I took a picture of Zayna going like this. I'll find a picture. I took a
Please don't
picture of
find a
Zayna.
picture.
And I sent it to my brother, and I didn't know where he was even in the country at the time because he traveled. And I'm like, we need a picture of you doing this because I'm telling my kids you have 4 fingers, you only have 9 fingers. And he's like, okay. So he was at lunch with, he was going like this. Let's have a picture of it. It'll be, we'll put it on the slide. So anyway, I knew Zane would remember that. So, I can do it, all right? Tangent and cotangent. Remember now, I should have already taught you this. They're short, okay? Y'all see that? They're short. These are long, 2 pi. Tan and cotangent are short, but watch this one more time. Tangents is on them, okay? What I mean by that is this. Okay. If I have y equals 3 tangent x, I'm going to say amplitude 3. Watch my pen. Don't look at Grace. Watch my pen. Tangent's not going to have amplitude. It's going to go off to infinity. Okay? You might want to look at your memo page at your IOU chart to help me in just a minute. Period. You're going to say pi over 1. Count, still the same. You're going to count by pi over 4. Okay? So the period is, and we'll write this on your memo page, but for tan and cotangent, they're little short people, okay? And so you're going to say pi over. My brother's also short, and he has 4 fingers. So anyway, they're little short people, okay? So you're going to count by pi over 4s. What is your phase shift here? 0, and your vertical translation? All right, so we have the added pleasure of starting at the origin this time. I hope you don't care where you start. You just count from wherever you start, okay? So right now, I'm going to start at 0, 0. If you're taking notes, don't write anything down right now. There's a reason for that. You'll have a chance to. I'm going to count 1, 2, 3, 4. I want to say with a tangent graph, I will never do that again. I will count out 1, 2, 3, 4, but not in that order. So watch. What's the tangent of 0? 0. What's the tangent of pi over 4? But it's multiplied by 3, so I get 3. That causes a stretch. Instead of 1, it's up here at 3. That's what significance the 3 has. What's the tangent of pi over 2? Undefined. What's the tangent of 3 pi over 4? Well, in the second quadrant, tangent's -1. Could be -3. Tangent of pi, if you need to look at your chart, 0. Okay, let's keep going. The next thing would be, well, I'll just do it here. This is what we have so far. Now, one thing I haven't talked about is what if I get closer and closer to pi over 2? I have talked about it a little bit. As I get closer and closer to pi over 2, what's the relationship to y and x? Y is growing and x is shrinking. Do y'all see what I mean? So y is getting bigger and bigger and bigger, and x is getting smaller and smaller and smaller, which makes the number infinitely large. For instance, if I had something like a y that was 8 over an x that was like 1/100th. Do you see it's gone off to 800? Okay. Now, if I actually drew the whole thing or typed it into my calculator, which I don't want to take time to do, but maybe I should. I'll do it. I think I should. All right, so I can't find it. Here it is. All right, I got to get rid of this little line anyway. It's driving me crazy. All right, so get rid of that. Get rid of that. Okay, so y is 3 tan x. I'm going to make my window 0 to, what did I have, pi over 2? Oh, here it is. Yeah. Okay. All right, are y'all look? Yeah. But girls, look up here so we can move on. Because you can be like me and have time to play with it later when you're thinking about it, okay? Now, watch me back up. I mean, that's what I have on my paper. I think you would all agree, all right? So now, I'm going to back up, though, and change my window. I'm going to go from negative pi to positive pi. Now I'm going to go from negative 2 pi to positive 2 pi. And I hope I can remember how to turn the axis back on this thing. Let's see. Need my axis on. Okay. So if you were the teacher, why in the world would you teach somebody to start at 0 and get half of a squiggle and the other half of a squiggle? Y'all see, it makes more sense just for me to start you back there and get a whole squiggle. Y'all see what I mean? Yeah. Okay? Because it doesn't make a whole lot of sense when you have asymptote right in the middle of the first one I'm trying to draw. So this is what we're going to do. We have an easy fix. Remember, where's tangent? The only T, not a CSC, over here by itself. Okay? Cosine's going to go back with the other CSCs in just a minute. All right? So what I'm going to teach you to do is this. Y'all ready? All right? It doesn't really have amplitude, but you'd need that number. If it makes you feel better, you can just call it stretch. That makes your graph stretch in both directions that way. Okay? I can change that number and change the shape of my tangent graph. Period is pi over whatever's in front of x. Count, you still divide it into 4 equal parts. And phase shift was 0, 0, our phase shift vertical translation. So here's my target, okay? What I'll teach you to do is count 1, 2, 3, 4 like this. Are y'all ready? 1, 2, 3, 4. Tangent's all alone doing that. Tangent's going to go 1, 2, 3, 4, but I'm going to go out 2, back 2. It still has the whole period, but you see the period got split over the axis, okay? So I'm going to go out, okay, and it's sort of like when I taught you how to factor a cube. Square the front, put it in the front, square the back, put it in the back, stick them together, put it in the middle, the last sign's always plus. This is going to go, I know, like along, I thought the same thing. You're going to go out to asymptote, back to asymptote, okay? So out to asymptote, back to asymptote. Then you are going to be confused which way to squiggle it. I'm just going to be honest with you, okay? However, as soon as you leave your target, due to order of operation, as soon as you leave your target, you're really entering the first quadrant. Do y'all see what I mean? From 0 to 90, where tangent is positive. So you mean that first mark will go up 3, and the second mark will go down 3. And then people have the hardest time drawing these. I get all kind of crazy squiggly. It really is kind of cute. But if you have a hard time drawing it, as I did, I found that I could pretend like I was going to draw a parabola, but stop, okay? So I'm going to pretend like I'm going to draw a parabola. Do y'all see what I mean? And then I'm going to pretend like I'm drawing an upward parabola, like my hand's going like this, but I pick it up and go like that.
Is it like a cube?
it looks a lot like an S curve. That's why I make sure that you do some more.
Okay.
So then, girls, wait. I'm going to go 1, 2, 3, 4, asymptote, middle, low, high. I just want you to draw a few so you know that these go on and on forever, okay? And it does have, as you head into AP Calculus later, they have a different derivative. They have a different slope right here. But they look very similar. They're both an S curve. All right, questions. Some will be answered if hurry up and get another one done before you leave. I guess we're not going to go before today. Go ahead.
Can you go over how you know which side goes up and which side goes down again?
I'll keep doing that. So let's do another one, okay? I might as well answer that with another example. All right, so let's do this one. Y is equal to 5 minus 3 tan of 2x minus pi, okay? All right, I'm going to go through this pretty fast because I want to get a cotangent in front of you so at least you can practice. Remember, you can watch the video. This one, not a, so
If it's a negative or positive.
hang on just a second. Okay, I'm going to tell you. You're probably right. All right, it doesn't have amplitude, but it has a stretch of 3, kind of like my amplitude, period. Tangent's the little short person, pi over 2, pi over. The count is pi over 8. Are y'all okay with that? Phase shift, anybody? Pi over 2. Vertical translation, 5. Okay. So I'm going to go to this. Pi over 2, up 1, 2, 3, 4, 5. My target's right here for my graph. I'm counting by pi over 8s. Those are really very small compared to pi over 2s. They're a fourth as big, so I have to think about that before I start. All right, I'm going to add them to pi over 2. So my next mark is pretty small, 5 pi over 8, 6 pi over 8. But what am I going to do with tangent? I went out 2. What am I going to do now? I'm going to go back 2. I go to my starting place. I go out 2, asymptote, back 2, asymptote. Okay? The dot is going to be right on this line, and then Katie and I are going to wonder which way we draw it. Okay? Immediately to the right of this, look at my dot. Immediately to the right of your target, tangent is positive. Unless you have a what tangent? Okay. Look. Unless you have a...
Negative.
I give you a negative tangent.
Yes.
If this had been a positive tangent,
Go up.
immediately at this dot, I would go up. But I gave you a negative tangent, and so immediately to the right of your start, it goes down 3. So it's going to hit here. This one's going to hit 3 above. And there's my first tangent graph. And you keep counting by pi over 8s and draw another one, okay? Make sure that you keep count back and forth till you've got a few of them in there, however many I asked for. Okay, so let me say a couple more things in the last minute. I'm going to graph a cotangent really fast as I continue to answer questions. If I have, let me just show you what you'll do with a cotangent. Everything's the same. If I have y equals 3, cotangent x, let's just do something easy. All right, so the stretch is 3. The period is pi. The count is pi over 4 from our target, which in my hurry I made 0, 0. So here's my target, okay? Cotangent is over here with the CSCs. Don't split it up. That's where you'll get confused, okay? It twists different and it doesn't split up. It still goes. These guys go 1, 2, 3, 4. So I'm going to go out 1, 2, 3, 4. Okay? I'm not going to go 1, 2, back 2. That's this weirdo, all right? So I'm going to count pi over 4. Well, they may not be weird. They may be so unique that they're absolutely the movie star. But either way, it's different, okay? Anyway, you'll go 1, 2, 3, 4. When you get to the end, put an asymptote. When you're at the beginning, put an asymptote. In the middle, put your dot. Okay? Now, go back to your target. Immediately to the right of it, every single trig graph should be positive unless I give you a negative. Immediately to the right of your target, of that little X that we all draw, everything's positive. Sine, cosine, whatever you're doing is up first, okay? So this one's going to have a dot at 3, a dot at -3, and then you're going to draw a few of them like this. Notice that it twists a different way. All right, so I'm going to say one more thing. I know we need to go. Tangent. All right, watch. You don't want to. I'm going to clear it up, Katie. Watch. On tangent. Okay? Whatever my target is, I go 1, 2, asymptote, back 2, asymptote. Dot in the middle. Immediately to the right, I go up. Do y'all see what I mean? What does cotangent do? Here's my target. 1, 2, 3, 4, like your graph and sine. When you get to the end, asymptote, asymptote. Immediately to the right of your target, where is it first? Cotangent is up here, 0 down here.
But what if it's negative? What if it's negative?
Okay, you talk yourself through it. You go immediately to the right, this will go up. Oh, but I have a negative. So girls, as you leave, the biggest question is a negative tangent looks like a cotangent.
Yeah.
But it's also shifted over, so I don't go there.
Thank you.
What if you have a negative?
Yeah, just do it backwards. Elena, if I have a negative cotangent,
It would look like a positive tangent.
but it would not be a positive. Right, yeah.
This is Eric. Can I